So, data structure. So, before studying, we must know what is mean by data structure and why we are studying data structure. So, what is mean by data structure? It's a particular way of organizing data in a computer so that it can be used effectively. So, you're saying something about manipulation of data in an effective format. So, manipulating in the sense, fetch and store data effectively. Okay, I could give you an example by means of library. As a student, you must go to the library and search for the books, and sometimes you may ask the location of the books to the librarian. The librarian say exact location. Why? Because he arranged the books in a particular format that is organized way. That is what is we are saying in an organized way. So why we are studying data structure? For that, we must know what is mean by data and what is mean by algorithm. What is mean by data means computer data is stored, processed information. The stored data as well as processed information is called data. An algorithm describes the way data is to be transformed, and the simplest way I'm saying is step-by-step way procedure of executing the program. There's no fixed rule in writing the algorithm. One thing is we have to explain the understandable format so that we can know how the program is executable. And now we are going to see the reason why we are studying data structure. Adding structure to our data can make the algorithm much simpler, easier to maintain, and often faster. Adding structure means we are increasing the complexity of the data. When we are increasing the complexity, it becomes more easier, more simpler. And building the data is somewhat tough, but when we manipulate the data, it's easier. And types of data types, and three types: primitive data types, non-primitive data type, and abstract data type. Primitive data type means basic data types that is present in the programming language, that is integer, character, boolean. They are predefined inbuilt. And non-primitive means by using the primitive data type we can able to construct some data types. That is what is called non-primitive data types, like array, record, union, etc. Abstract data type means we are developing some data types by using the mathematical model, the mathematical formulas, that is queue, stack, tree, graph, that is sets, matrix. Like this, we are using some formulas. So mathematical models, then that is what is called abstract data types. The basic operations in data structure. And basic operations are traversing, searching, inserting, deleting, sorting, and merging. Here I have to say something. Each and every operations are interdependent to one another. Why I'm saying this is traversing means accessing each record only once so that certain items in the records may be processed. And finding the location of the particular location by using given key or all the record by using one or more conditions. Inserting, adding a number, adding a structure, adding a record, deleting a record, and sorting means sorting data, and merging means compiling the record. So what I am saying they're interdependent means while travels we have considered searching. Searching means we are searching an element, for example 1 to 5. We are searching 1, 2, 3, 4, 5, and we are searching element 3. And for that must travel from location 1, location 2, location 3, location 4, and then location 5. So with a given condition we are searching, that is 1, 2, 3, 4, and 5. 1 equal to 3, we are searching 3, 1 equal to 3, no, the condition fails, so travels next. That's 2 equal to 3, condition fails, travels next. So 3 equal to 3, then we are finding a location, print it. So here the two operation handles, that is traversing and searching happens. In inserting, traversing, searching, and inserting. Find the location, searching means find the location and inserting. As we're traversing from one location to location, searching for the location, and inserting. When you find a particular spot, we are inserting something. So deleting, the same happens. Inserting, the same happens. With condition, it searches some elements and comparing it and then sorting. Merging it also, it happens something. And array. Array is a container which can hold a fixed number of items, and items should be of the same data types. That is mean homogeneous data types. Array is a homogeneous data type. It's a container of homogeneous data type. Why we need array? When the program need to manipulate many variables of simpler form of data. That is, if you want to manipulate 100 elements, so that we can in 1, 2, 3, 4, like this, it keeps on going to up to 100 times. It's tedious, it's impossible, it's tough, very tough to maintain it. So we can say it by means of simply say it by means of array. that is int array of 100. It can hold 100 elements. Okay. So here I'm saying something, that is, as the complexity of data structure increases, it becomes more easy to deal with the data. So what is the complexity? I'm saying is array of a int array of 100. The complexity increases. We can manipulating by using a single variable, that is array. If you are not using an array, what you are going to do is a of 1, a of 2, a of 3, a of 3, that will go up to 100. So it's tedious, it's not possible. So next, and times of array. What is memory element and what is main index? Index element means item stored in the memory in that array is called element. The index means the address of the element. This location shows the location of the element in an array. So array representation, basic representation, that is integer array 1 3 equal to 1 2 3. That is integer means data type. Array 1 means array name, and 3 means it stores the number of elements that we can able to store, and 1 2 3 is the element we are stored. So basic operation: traverse, insertion, deletion, search, update. So insertion operations: insert one or more elements. It's linear array, linear array, linear array. This we're saying some linear. Example: n is the number of elements, k is the positive integer. That's k must be always less than or equal to n. Start. Set j equal to n. Set j n equal to n plus 1. That is, you are incrementing one element. I repeat step 5 and 6 while j greater than or equal to k. Set L of j plus 1 equal to L of LA of 1j. That is, we are adding an element in the file in the end of the line. That is, j plus 1 equal to L. Set j equal to j plus 1. Set k equal to I. Okay, let's start it. So I have to say one thing. That's algorithm next. What is an algorithm? Step-by-step analysis of the program. So writing algorithm, there is no definition for it. The only thing is we can understand what is going on, what is happening in the program. Okay. And deletion operations, removing and reorganizing. Removing and reorganizing in the sense we are removing one element, that is 1, 2, 3, 4, 5. There are 5 elements, we are removing 4. After that, the location of 4 is empty, and we must release the storage place of 4 and reconnect and place the 5th element in the element of 4th. Let's reorganize then. After the removing the element operation, removing operation 1, 2, 3, and 5. So what is that? Okay. So algorithm, linear array of linear array, n is element and k less or equal to k. N start j equal to k, repeat 4 and 5 while j less than n, and set j minus 1 equal to L if j. That is, j minus 1 location will be that is, we are using jth element and place it in the j minus 1, and j minus 1 place element will be deleted. This is what the actual meaning. And set j equal to j plus 1 and n equal to n plus 1 will start. So updating an existing element of an array at a given index. So we are giving an index of the location and just delete it. And start set linear array of k minus 1 equal to I. In k minus 1 place, we are deleting the element and place it in the new element, that is step. Searching operation, searching based on index or value, that is start set j equals 0, repeat 4 to 5, 4 and 5 while j less than or equal to n. If L linear array of jth element is equal to the item what we are going to search, then set j equal to j plus 1. Okay. Then print j of item. In jth element we are printing an element and start. String. Before that, we must know one thing: what is string and what is an array. Array is a homogeneous data type. String is not a homogeneous data type. We can store any types of data type: characters, null characters, integer, alphanumeric characters, whatever it is, we can store it in the string variable. Here, string will be always terminated by means of a null value. So if you want to store 5 elements, you must need a place of 6 elements. Why? Because the last element must be null characteristic, so that only we can able to know the string end at this place. So some functions: string copy, string concatenation, string length, string compare, and string characteristics, string str. And first, string copy. We are copying s2 to s1. That is, s1 contains 1, 2, 3. S2 contains 1, 2, 4, 5. After copying that, S1 becomes 1, 2, 3, and 4, 5. String concatenation is the same thing, but it's just adding something. That is happy birthday means S1 is happy and S2 is happy birthday. So after string concatenation, it joins together. It's not copy, it joins together. That is string copy, and output will be happy birthday. So string length of this one, it shows the length of the location. And compare, string compare, CMP means comparison. It compares whether this element is greater than S2, S1, S2. That is logical operations, less than, greater than, equal to, like that, equal to, the less than or equal to. And the string characteristics return a pointer to the first occurrence of the string ch of S1. That is what means hello means we are searching. L means it shows when the first L occurs, that is HELLO, that is third location. Okay. STR means S1 of S2 means it shows location, that is the address